Hello, everybody. My name is Martin Müller, and I will be guiding you through this course about Spock testing. And first of all, we will see some difference, hopefully, between standard set, which is, I guess, a mainstream for testing, which is JUnit and Mockito, and Spock here, which is the thing I would like to present you, and possibly to also give you some feeling like it's a sensible replacement of your tech stack, the default one. So what's the benefit of using Spock over JUnit plus some mocking framework? We will see on an example. So here's the motivation. First of all, we have some method. I will go with this laser pointer, okay? So let's have a method on our repository. We have some database, we have a repository, we are asking for data. And we are searching for data using either phone, you can see it here, or by email, whatever will work. And for this method, we are doing some testing. And we would like to possibly also use mocking, like providing some fake data for our test cases. And in case you are using JUnit and Mockito, it could look like this. It's not something that is not usable, but in my point of view, it's a lot of code, and just portion of it actually means something, like the part here. We are calling repository, and when it happens that find by phone or email method is invoked with anything inside, we are trying to put something as an answer, as a fake answer. That's mocking about. And the fake is we are picking email here, and we are creating a new instance of customer with that email. So somebody is asking the repository, and we are providing new instance of customer using the email provided. And a lot of code is there, just as we call it boilerplate code, like something that is a necessary evil. And Spock is about minimizing of this necessary evil. So that's the only thing that means something in my point of view. That's the only important part of the mocking behavior described. And in case we go into the Spock, you can see down there. It's much more simplified. We are just creating mock here. And then we are only specifying important information. So you can see when somebody is calling our method, having two arguments, and we don't care. That's the Spock way to say we don't care, underscore. And what we do, we are providing some mocking behavior. Those two arrows to the right side, that's mock behavior written in a Spock. And in curly braces, you can see some logic, what's actually happening. We are picking the second argument. We don't care about the first one. Yeah, first one is ignored, hence underscore. And the second one is email being input for customer construction. And this is much more concise way of saying the upper thing, which is in JUnit and Mockito, just ignoring all the boilerplate and using only important features. What are we calling and what is the outcome? And that's the result of Spock. And I would like to use Spock as much as possible in my projects, because I would like to read my test code as some kind of documentation. Like you can immediately see what's happening there. And in case you see some business cases encoded in a way like this, you can see what is your production code meant to do, in case it's so clear, in case it's not so verbose as Java. So it's much more concise than Java. That's the first thing. And the second thing, we have some additional features. Like you said, those double arrows to the right side actually means mocking, for example. And that's just a shortcut. And we still use standard JUnit runner, which is a mainstream for every, I don't know, Spring Boot project, for example. So you do not need to bend your project or destroy anything. You just add more libraries like Spock core, we will see it in a moment, and you are running your old tests. You can keep your old tests, and you are also adding new tests, possibly written in Spock. So both solution, old JUnit and the new Spock, are allowed to work together. And the killer feature for me, in case you would like to use Spock, is parameterized testing. I will show you in the demo session. It's actually something that is also available in JUnit, especially in JUnit 5. You can have multiple cases, cases of the same test scenario, but it's not so widely used in JUnit. I have seen only few people using it in JUnit, but every Spock developer I know uses parameterized testing heavily because it's so easy, and it's actually useful because in case you would like to have a good test coverage, you need to have some positive scenarios, some negative scenarios, some edge cases, possibly some exception throwing scenarios, and all of this should happen so you know what are the possibilities and you have tested them all, not just some happy way. And that's why you need parameterized testing, and it's excellent. Now, the last thing on the screen, labels for all phases. It's something that's connected to the behavior-driven development. You maybe know the buzzword BDD. It's just some way how to split your tests so you know what's the starting condition. Like there is some preparation, some stage set. And when we have some prepared entities or classes or whatever, we are going to actual testing. This is the when something happens. My test event happens. And in the end, there is some lower block, the last one, and it's called then. We are doing some assertion. We are asking for verification. Is this true? Is this assertion working? So that's how we divide things in BDD. And Spock is BDD framework. Few more features. There is integrated stubbing and mocking, meaning you do not need Mockito or PowerMock anymore. You can exchange JUnit plus Mockito for just a single thing, Spock, because mocking and stubbing is already integrated. And I will show you something to start with. There is also possibility to document your methods, like name them in human readable way. And this is how it looks like. So on the left side, you can see some test is just some dummy example when we are creating some customer. It can be customer as a private person, or it can be company. And left side is Spock way, and the right side is JUnit way. It's not something that's not usable, not at all, but you can just see how clear, short is the left side comparing to the right side, because we are creating here that way the customer. That's my favorite test customer. And on left side, you can see in Groovy, because Spock is a Groovy thing, we are using Groovy language to construct our things. We can do it on just a single line. This is actually Spock way or Groovy way to call setters. So it's totally the same thing as the right side. We are just doing it without any necessary lines. So we are creating one customer, second customer, and this is our given thing. As I said, in BDD, we are having given and then some testing and then some assertion. And that's it. Our assertion down there, we are just asking whether something equals, and that's it. We do not need any assert keywords or assert something through parentheses and stuff like that. We just ask whether something equals, and that's it. Every single line in this part of test is expected to be assertion. And in case it produces fail, like false Boolean value, it's considered failing test. In case it will produce anything else, it's passing test. So it's also the same thing as on the right side, it's just shorter. And this is a really small dummy example, and we will show you much more complicated scenarios soon. Anyway, let's start with the basics. First of all, we are using Groovy language, so we will go into the Groovy details soon. Now, please look at the standard look of the Spock specification. Specification is something we are used to call our test case. It's not test like in JUnit anymore. It's a specification. And every time you write a new test, you need to extend specification. That's it. No annotation like test annotation in case of JUnit. We just extend specification and that's it. Then we can write methods that have human readable names. You do not need to use any snake case or camel case or whatever case you use for your test. And you can write a sentence like a normal human, and it's actually pretty readable. And you can see first block gives you some playground definition. And in second statement, we are expecting something. This is just a dummy example, expecting modulo of 2 will equal something, but we will go into complicated examples soon. Before that, we need to know some Groovy basics. First of all, Groovy is not like Java or Kotlin. It's dynamically typed language, meaning you can, on one side, have type inference, because it's possible to write type like integer, but we can also write just this def, meaning this is the definition of something, and it will be inferred from the right side, because obviously it's a number, it's an integer, so you do not need to write it. And since this is dynamically typed language, we can also assign something else into the variable, like a string there. It's valid. I don't recommend this, but this is something that's feature of a Groovy language, and we are building on Groovy. Then we also have def keyword in a method definition. So we can write something like in Java, just a keyword that is a signature name of the method, or down there you can see some string, some sentence that is describing your case. And this is actually something I would recommend, like in case something happens, your test should do something or prove something. So when, then. And this is what makes your test scenarios more clear, like what's happening there, what should happen, what you are testing. In some cases, you can also benefit from string interpolation. It's something you can know from Kotlin language. You use a $sign, and you can put one string into another string, like concatenated. So that's another Groovy language feature, and Groovy has a lot of features. We will go just through the basics. And one of them is, again, present in Kotlin, double equals operator. This double equal operator actually means dot equals in Java, because when we are comparing two instances, we are usually not asking for object reference in heap, in memory. We are asking whether thing 1 and thing 2 are equals by the content. So this is being translated in a background to dot equals. Closure is something like lambda. We have lambdas since Java 8. And here in Groovy, we have something that is a bit more powerful. This is something you can store as a variable, and it's some logic, some behavior. And for example, here we are printing whatever is the input. And it is implicit name for a variable that is being pushed into the closure. You can again know it from Kotlin language. And here is a usage on line 4. We are calling our high stored closure, and we are putting a high value inside. So this input argument is being transferred into it variable, and this is what we can work with. It's just a dummy example, but you can use this in your mocking, because your mocking is not just providing some prepared instance. It can also be some dynamic behavior. You take some argument that is coming from outside, and in your mocking, you create a new instance, you do some calculation or whatever, and then you return some response. So that's where you can use closure. Another 8 examples. You can see it, for example, here. This is some collection and another collection, and on those collections, we are testing. This is assertion. We are testing whether every member of the collection contains something. For example, here, we are asking about the member. This is the it and a variable, whether the member status equals something, or whether updated timestamp is not now. So this is how we use it in practice. Now, what do you need to have in case you would like to start using Spock in your Java project? You can use it in Java project, in Groovy project, in Kotlin project. Actually, in my team, we are used to have Kotlin as a production language, and we are using Spock and Groovy for testing. So that's a completely valid setup, and you can also have it for Java, of course. And JUnit 4 is okay, JUnit 5 is also okay. You can keep it and just add whatever you need. Spock core, in case you are not a Spring user. In case you have a Spring Boot project, you can use Spock Spring, which has some nice integration for Spring test runners. I expect you also would like to use mocking, so you need some code generation library. For mocking, you can use Ciklum or ByteBuddy. And last but not least, in case you would like to use Groovy language, you need that dependency, of course. So that's what you need. And you can start with Spock writing some tests. This is example scenario. So what you should know. You extend specification. We already told that. You should write some human readable sentence like, when something happens, something else is expected. And I guess JUnit developers mostly try to use some very, very short names because it's not very readable in case you use a long sentence. But it's not something you are forced to with Spock. This is just an example. You can see when my email notification equals something, it should be set to some other variable. And this is just a sentence, a human readable sentence. In case you will try to run this test, it will result in some human readable outputs. I will go back to the test in a minute. Okay, of course it failed now. Let's keep it. Then you are free to put, in case you would like, some label also to the given, like test preparation, and when, like event invocation, and then like assertion. So you can have also test labels here. In case you have some very complex test case, please use it. In case it's just straightforward logic, you can omit it and have just a given and your stuff. Assertion down there is completely optional. You can have just a number 14. Something equals, yeah, number or string or whatever. You do not need assertion like in JUnit. In case your test will fail, Spock has quite nice, in my point of view, error or exception reporting, because you can see what actually failed. In my test case, I have here something simple. I'm just asking for a variable having some specific value, literally. And in case it's false, I will see here, using those two pipes, what value was provided in a variable. In case I have something more complex, it can be very, very handy, because imagine you have some method chaining, you are asking for some method being executed on a service, providing something inside, and there is a long chain of calls, and you can see what values are inside like this. For example, here I'm asking for having a maximum value of those two, and I can see here that one value is 0, another one is 7, maximum of it is 7, and it's not equal to 4, which is C variable. Sorry for wrong formatting, but I guess it's readable. So this is a small example of Spock usage, like the base dummy scenario, and we will later go into something real. I would like to show you what blocks, I mean BDD blocks, are to be used in case you would like to use full power of behavior-driven development. We already encourage it, given that's data initialization, like something that is being put into your test. Then there is some when condition, like when something is happening, my test triggers. And then we are asserting data. In case you would like to use a shortcut and put when and then together, you can just ask for expect. Like I expect some computation to equals my value. Possibly you can use cleanup because you would like to close the stream, you would like to free some resources, or you would like to var, and that's what's actually nice. That's parameterized testing. So how it looks like, expect is, as I said, you can combine together some calculation, for example, and some expected value. So it's when and then together. And this is cleanup. Cleanup keyword we have seen, we are closing file access, so we are freeing some system resources. And now here's the magic. Here's the parameterized testing. We can have something like a table. Table contains 3 test cases. You can see on line 7, 8, and 9. There are some cases for our calculator, and you can start it up and see how it will behave dynamically. I actually can show you a real-life example. I hope it will work this time. So this is in my IntelliJ, and you can see I have simple calculation here. And for simple calculation, having just 2 numbers in your test case is not enough. You need to test some positive cases and negative cases, like I'm asking whether input 1, x variable is negative and this one is positive, and vice versa, and both are positive. So I would like to test few cases, so I know my calculator is not just a dummy thing, but it actually works. And I can use my parameters in parameterized testing also in the name of the test, like this, using hash. This is a placeholder for my x variable, and another variables I have here. Using 2 pipes, I'm able to distinguish what is input and what is the result. Usually, by convenience, on the right side is the result, and on the left side we have some parameters. And down there you can see how it looks like in your IntelliJ test report. And a similar way it would look like in your, I don't know, GitHub or Azure, whatever CI/CD you use. What does it mean? In case something goes wrong, you will see particular test case with particular values that is not passing, which is interesting because you do not need to go into the log. You see some basic stuff already in the test name. Let's go back to the presentation. When using parameterized testing, you can also use something that is much more powerful than just writing new test cases in some kind of table. You can, for example, here connect to the database. We are connecting to the H2 database in memory, and we are selecting some test cases, pushing them using this left arrow operator as parameters, as a name and email into our test case, meaning your test engineers, for example, can prepare some database table with, I don't know, 1,000 test cases, a lot of values, and you can load them easily and put them into your test case. So you do not need to maintain this data, you just run it. This is another way how to do it. You can define variables independently. And when everything goes wrong, this is my test case. I just showed you the calculator. When everything goes wrong, you can see what's the result, what's the cause actually. So you can see on left side which of those test cases failed, which values are there. You see it already in the test name. And on the right side, you can see in log some elaboration, like what was the first argument, second argument, what was the result of plus operation, and why this thing is not equal to the expected result. In case you will have something more complex, like a long string, Spock is also helpful in that way. You can see it like that. This is just a simple example, and I was providing this this is just a simple example. This is correct spelling. And you can see M is missing in a symbol here. So the test is telling you that there is one difference in that string. There is next 96% similarity. And you can see down there what is actually missing. The letter here is highlighted. So this is again another thing Spock can do for you in case you have not number but string comparison. You can click to see the difference, and it will show you in IntelliJ as a comparison window, as you are used to in case you do version control thing like committing and pull request. You definitely know this. So you Sam can see this. From JUnit, we are used to have some method that will prepare our playground for our test case. Like we are, for example, before every test, doing some initialization, or we are doing some static init block before the whole test class, or after it, we can do some cleanup, for example. And we have similar thing here. It's called setup or setup spec before the whole class, or cleanup after every method, or cleanup spec after the whole of it. And you can see it with comparison to the JUnit. There is a direct mapping, nothing special. You can easily understand what is set up and before. In case you have some very special requirements, or it's not so special, in case you would like to test your negative test scenarios, you would like to test exception throwing, you can do it like this. You just ask in assertion block whether something was thrown, and you can put there whatever type of exception you need. So you can be specific, or you can be abstract and just put there throwable or exception like general. And in case your exception will be not thrown, or not the right type will be thrown, you can see exception report down there. This is how it looks like. No exception thrown. So that's wrong. Last specific feature I will show you before the demo. There is a possibility to ignore your test in specific condition. I do not recommend this because this is a code smell. This is something that tells you that you have architecture issue. Anyway, in case, for example, you would like to ignore your test in a macOS environment or for Java 7 environment, you are free to skip it. Or on the other side, you can say that just for Java 8 environment, this test will be executed. It's a hacky, and I don't like it, but it's a possibility. Now, let's go for mocking and for real-life examples. In given block, we usually create some mocks, and it's being done like this. Just put mock keyword and whatever class you need. It will provide you with a new instance of that class in parentheses. So my mock is here, prepared. I do not need to specify the type, just the def is enough. The type will be inferred from the right side. Then we can use our mock also for construction of our user service. We are putting the mock here. And in the end, we are telling our mock how to behave. What is expected mocking behavior? In case somebody is calling get method with whatever argument is there, it just has to be string, but whatever argument, we are providing by 2 arrows some behavior. This is a closure. The curly braces define some logic in a closure. And we are taking whatever was put inside the string, we call it email, and we are creating a new user instance with that email. This is the way how to call setter in Groovy in case you would like to make it short. I guess it's very readable, and you can see this is a language that is specifically designed for mocking. This is how some more complex test scenario could look like. We are again creating mock of our user DAO, and we are telling there that in case somebody will call delete method with whatever argument, we don't care, underscore, we will first return true, and then for any other consequent invocation, we will return false. So you can actually switch your behavior in some sequence. You can see down there. First of all, we expect that this invocation will be true and false and false and false, on. We are also able to do something that's necessary in mocking to ask whether some method was invoked or not. How many times? With what arguments? So we are checking possibly whether, for example, some email was sent, whether some repository was called or not. And we can do some quantifying. Yeah, here we can use ranges. This is the Groovy way how to define a range, like from 1 to 10, for example. And we can also define what type is the argument on the right side. And this is time for demo. So I will show you, first of all, this example. Now, after explanation of Groovy basic and stuff like that, I can tell you what's there in more details. I'm constructing a new customer. A new customer is being constructed using some user email. This is like a username and also a primary email, the default one. But in case you would like to use some special email just for notification, you can also define some notification email as optional value. And I would like here to test using parameterized testing 3 scenarios. First of them is I will put just a null value like nothing into notification email, which is optional. Second of them, I will put there something, but not usable because it's empty. And third is I will actually specify something as a notification email. User email is always filled because it's mandatory. It's like a user ID. And I'm asking, this is divided by double dash, I'm asking what will be the resulting notification email here in my expected block. When I will call such a test, it will produce 3 test cases, 1, 2, 3. And my values like notification email or user email will be also interpolated here into the name of the test. So it's much more readable in your, I don't know, continuous integration and continuous delivery machine. And we are also covering various cases with just a single test definition. We are not forced to write some positive test and negative test. Everything we need is to write test once and put there few arguments. Now, something more complex. Now, we are using power of Groovy to define new instances easily. We are able to create new customer like this, for example. We are saving new customer into database, and we are using so-called map construction. Map construction means you are using map because this is actually map. Key value, value and key are separated by column. And this is short way to use setters in Groovy. So this is actually calling set user email, and this is a value. And this is set company, and this is a value. And we are constructing customer this way, even though there is no constructor using all those values, because those are actually setters. So in my test, I have some preparation. I have in a given block, as you know, some preparation. I'm creating some new values here in single line. And in the end, I'm able in Groovy to define some special string using triple quotes. In such a setup, I can use special expression, for example, $, and it will be automatically interpolated, like the value will be filled. You can see customer, this is a value. This is a variable up there. So I'm using ID of my customer that was saved into database. So from database, my customer has a value. I'm putting it there. And what I'm doing actually is I'm creating JSON document that will be sent in my when block using mock MVC. In case you do some Spring Boot testing, you probably know that for testing of your controllers, your REST controllers, there is a mock MVC you can use, for example, post on some URL, and you can send there JSON like the JSON I have prepared here. And yeah, in the end, I'm asking in my assertion block whether my database contains something. Because I was posting, like I was saving my instance into the database, I'm checking the content here. In case anything is not clear, you can ask as you wish. Let's go for something even more complex. Now, to let you see what's there, I will explain. We are trying in one of my Czech project to send email. We are building a message body. And in that message body, we need some customer. You can see it here. Yeah, Darth Vader again. And we are having some company that is actually selling the good. This is the shop center. And in the end, we have something that we are selling or we are buying as a customer. This is product 1 and product 2. It's a lot of data, and we do not need to write all of them line by line using some setters. We can just use for convenience inline construction when suitable, and multi-line in case it's just too much values, it's too long. So I'm preparing customer here, I'm preparing shop center here. There is no such a constructor as you can see here. This is actually calling of setters. New instance of shop is being constructed here, like in line. And all of this is then being concatenated using string interpolation with body of my email. The white values are the places where string interpolation works. And what's that? Where are those variables coming? They are coming from down there. This is a heavily parameterized test, and it's asking whether customer is company, whether customer is taxpayer, and whether on the other side shop is taxpayer and stuff like that. And there are various possibilities what can be filled in your customer profile, in the shop profile, and for various cases we are expecting various outcomes. Up there is what's coming inside, and down there is what text are we expecting. Like our email body builder should be prepared for all the cases, whether there is some tax number or is missing, whether there is some phone number or is missing, and stuff like that. So this is parameterized testing with connection of string interpolation. So now go for something else. I will show you mocking. Again, please try to imagine for a second how we would like this method name to be written in just a camel case or snake case as we are used in JUnit. In case you do Spock testing, you can write freely whatever you need, and it makes sense as a human readable sentence, and it's a nice feature. In case you have complex scenario, you can also have just names there. So one big name of the test case and some names for the states, like what's given, what's happening when we are testing, and what we are actually asserting, what is the verification about. So what we are doing, we are creating some new instance of some response object. And again, using mock MVC, we are testing the REST API using post, using JSON, using input data we have prepared up there. And we are providing some mocking because we are saying here, I would like to assert that my send request method will be executed exactly one time. This is quantifier. It will be executed one time with this in parentheses is what's argument. I'm checking that argument has some properties. This Boolean is true, and this Boolean is true, and this Boolean is not true. Like it's not a test. And in case something like that will happen, somebody will really call it. I'm filling their mocking environment, the mocking behavior. Mocking behavior, like my prepared response, I have prepared here, my prepared response will be returned. Plus, I'm testing that status is okay, like HTTP 200. In case you have nice test case and you are glad you have it, and you would like to put some more assertion inside, but it's not really related, you can chain it using AND. Like here, we are testing something. We are testing that some properties of a message are filled. And here, we are testing something else. So we have it divided into two blocks. Then something is happening, and something else is also to be happening. So we are now here just testing that content as a string of our REST API return is having some exact values, like our JSON response is having exact data. Okay, so that's it. And some more mocking here with exception throwing. Again, you can see quite a long sentence, but it's descriptive. Time exception should be thrown when a response file is not received within timeout. I think there are no unnecessary words in the name, and it's well understandable. It's not so complex case, so we are missing labels in given, when, and then. We are just saying here that every time somebody is asking our file service for a file path, we are providing some dummy path. This is mocking behavior. And what we are expecting, since this is just dummy stuff, and this is not a real file, we will never ever receive the file, timeout will happen, and timeout exception, which is our specific exception we have constructed, this exception will be thrown. So this is example of negative scenario test. Okay. Morphing on the same category, negative test scenario is here. You can ask two things. One is whether something is thrown. On the other side, you can test your, for example, REST API. Like in my content, some exception is being serialized. So this is in my JSON asking for what exception message is there. This is another test case. And again, with quite a lengthy name. You can see that parameterized testing, which is this, and you can see it also in another examples, like here I have shown you, or here in our notification and user email. Parameterized testing is a thing we are using all the time in Spock because it's so easy. And in my point of view, it's crucial to have coverage of test cases that are positive, negative, and some edge things, like something that never happens but possibly can happen, so you have to test it. So that was something about mocking. And now, in case you would like to have some easier time with your Spock implementation, you can install some plugins that are there for IntelliJ to ease your start. I guess you know something like private static void main live template, like you could just write, and it will tell you that you can insert private static void main. So you can do something like that also for Spock in case you will install the plugin. SP, like Spock, And then you can, for example, write given, when, then. So given, when, then, you can see it all there, Spock, given, when, then. And it will just generate a skeleton of the test for you. Nothing special, nothing big, but in case you are not sure how to write your first test in Spock, this can help you. So for other test cases, like for parameterized testing, there is another live template, like where, you need where. Oh, even dark. Okay. For example, this, you can have given, when, then, where. This is parameterized testing. Yeah, where is the parameter thing. So this is something that can ease your start with Spock. And I will tell it once more. You can have both JUnit tests and Spock test in one project. It's actually something we have, because in our project, we have one legacy application. The base of it was written in Java and JUnit. And later, we started to use in a team Kotlin as a primary production language and Spock as a primary testing thing. And it's easy because we can have both Java and Kotlin code in production, like incremental migration, everything that is new that is written in Spock, Kotlin. And for testing, we have the same. Legacy code is JUnit and Java, and everything that is new, we write it in Groovy and Spock. And when we touch something old, we possibly also convert it into Spock. And for Spock conversion, there is some help for you. I will try to show you. I hope I will succeed. Okay. This is a test case when I'm creating some product and some wish list and client. What is it about? It's about our client being Dartmoor Sitlord, and he wishes to have some new gear. He would like to have a new Sit infiltrator. So this is a product. We need to set a name for it or code, put it into collection of wishes, and finally, for the client, set that wish list so we know Mo actually wants Sit infiltrator. We save the data and flush it into the database, and then using our REST API, we are asking whether we are able to find the client using username, which is just uppercase, concatenated first name and last name. Yeah. And this is something that I have showed you in the beginning, and we could possibly, using code tab up there. Similarly, as you can use Java to Kotlin conversion, you can also use JUnit to Spock conversion. It will ask you whether you would like to add Groovy into your project, because for the first time I was missing Groovy. Okay, minor polishing here. And it did some basic conversion. Now I have Spock. You can see its specification. You can see that there is a def when we are defining a new method. And this is just basic conversion to give you something to start with. And in case you would like to make it better, you are free to do so. You can already see that, for example, get code is shortened because shortcut for this in Groovy is just code. We do not need to call getters. We can access it like public fields. In the beginning, getter is being called, but we still can do better than this, like take the value and put it using map construction here. The plugin will not do this for us. We have to optimize the code ourselves. But my point again is, in case you are starting with Spock, this automated conversion can help you out in case you are unsure what to do first. So what I'm using JUnit to Spock converter. That was the plugin recently demonstrated. And I'm using Spock framework enhancement. This is the live template thing. Like I was typing just SP and it was auto-generating skeleton of the test for me. Last but not least, there is Groovy console. We are using the new language, Groovy, not Java. And in Groovy, Spock was created using its special syntax. In case you are not sure about Groovy, you can see something in your IntelliJ. It's already integrated. You do not need to install anything. In tools, there are things like JShell. This is an interpreter for Java. And for Kotlin, you can also have REPL there. And for Groovy, there is a Groovy console. There's the thing I have here. And you can write any expression and let it run like this. So this is, for example, the way how to define a range of numbers in Groovy. And by calling a collect, I'm collecting it into a list. So this is a result. You can see immediately a result down there. So this is a tool for you in case you are not sure about the Groovy language. Let's go back. So this was for JUnit conversion, live templates, and some real-life examples. We are almost at the end, and I see some message. Okay, are there any libraries for mocking and testing Kotlin coroutines with Spock? Actually, I'm not ready to answer this because, to be honest, in my Kotlin project, we are not yet using Kotlin coroutines, unfortunately. So I'm not ready to answer how Spock works with this. Sorry. I could just say that for anything I'm normally beside of coroutines. So for everything else I'm doing in Kotlin, I can very well test it with Spock. We are using this on like 5 projects currently. The setup of Kotlin plus Spock in a test case, and it works very well. We were also looking for Spec. Spec is some behavior-driven testing framework for Kotlin that is written in Kotlin, and it's inspired by Spock, but it's not so good. It's not so powerful, and also mocking is not integrated inside. Okay, this presentation will be there for you, and some project I was showing will be also there for you, and it will look like this. This is the wish list, the Darth Vader's wish list, and you will see the code, the default, which is in Java and JUnit. And in case you will go into the Kotlin branch, you will see totally the same thing, just written in Kotlin, and the test scenario is written in Groovy and Spock like this. So this is in my GitHub, and we will provide you with this. In case there are any other questions, please ask now. I'm here for you. And I will just sum it up like there are some references for you. Spock even have a web console, so you can try it out in a web environment if you wish to do so. There is some cheat sheet for you, like you are doing the transition from JUnit to Spock, and you need to know what's the right keyword in Spock. So there is a cheat sheet and some nice introduction article written. Yeah, it's my favorite. In case you would like to use Spring with your test cases, and you would like to put your mocks into application context, like replace your real-life production, let's say, service class with some mock you created, you can use Spring Bean annotation. It's there for you. It will make your context dirty, so use it with caution. Anyway, it's some counterpart of Mockito inject bean. So you can put your thing into application context and have whatever behavior directly in application context of Spring. And in case mocking is not enough, like defining a fake instance that is having a fake behavior, you can also use spying, which is similar like mocking, but you are using real instances. You are wrapping the real instance into the spy, and you can ask how many times my method was invoked on a real object, how many times it was invoked, and with what argument. Yeah. So spying is another level, and it's also integrated in Spock. I was just not showing it here because of time. So thank you for your attention, and now is the time for Q&A.